Hey everybody, in this video I'm going to show you how to conduct a multiple regression analysis using SAS Studio from beginning to end. So why don't we get started? So for this video we're going to be using a data set called body fat. So if you take a look at your libraries and go to your other library, you will see a body fat data set. So let's just take a look at that for a moment. So what this is it's a data set that tries to predict the percentage of body fat in a person using a variety of variables such as age, height, weight, and then also circumferences of different body parts in centimeters. So what we're going to try to do is we're going to try to create the most effective and statistically significant model that we can. Remember, what we're trying to do here is figure out what are the actual variables or covariates that are the most important for predicting the body fat percent. So here, as you'll see, we have about 13 variables that are supposedly helpful in predicting body fat percentage. But what we want to try to do is minimize the number of variables we use to only including statistically significant ones. So before we do anything, we have to take a look at our data. And there are a series of conditions and assumptions that have to be met. So we're going to look at a few different things. And we're going to look at the linearity condition. And in order to do that, we want to take a look at what a scatter plot looks like when we plot each one of these covariates against the body fat percent. What we want to make sure is that each of the relationships between these variables are linear. So we don't want to see any kind of non-linear relationships between these variables in body fat percent, because this is a multiple linear regression. If we wanted to use variables that have non-linear relationships between themselves and body fat, we would have to use some other kind of regression model. So we're going to want to make sure we check the linearity condition. And then we are also going to want to check the equal spread condition. We want to take a look at the residuals between age and body fat, and we'll eventually check that as well, and height and body fat and all the variables that are left over. We'll take a look at that at the end of our regression analysis. So when we have the variables that are final, the ones that we say are actually significant in predicting body fat, we want to look at the residuals of that model. Okay, so we're going to kind of do all of these things step by step together. So the first thing I'm going to want to do is I'm going to want to create those plots between each one of these covariates in body fat. So we're going to want to create those scatter plots. So I'm going to go over to my tasks in utilities, and there's a couple different ways you can do it. Of course, you can use the scatter plot task, which is under the graph section. So you could use the scatter plot task. The big downside to this is that you can only do one scatter plot at a time. So if you have, like we have 13 variables, it's not that you can't do it, it's just going to take you a lot of time. So we're not going to use that. So there's a lot of different things we could take a look at, but I'm going to use the correlation analysis task under statistics. That allows us to create up to 10 scatter plots. So yes, you're right, you're going to have to run this task twice to get all of the plots, but hey, it's better than running it 13 different times. So we're going to use the correlation analysis. And the other thing that actually helps us do too is to take a look, it helps us take a look at the correlation between each of these variables and body fat percent. So while we're at it, we can say, hey, you know what? If it doesn't look like this variable has a correlation at all between themselves and body fat, maybe we want to remove it right off the bat. So let's go ahead and start with that. So we're going to go to correlation analysis. And I already have my data set to other.bodyfat because that's what's open right now. And for your analysis variables, you're going to add columns, and you're going to pick everything but the variable you're trying to predict. So we are trying to predict body fat percent, so we're going to select everything else but. Now, I'm selecting, notice I'm selecting all of the variables. It's not going to create scatter plots for all of these. It's going to limit us to 10. So we're going to have to go back later on and do the last few, but might as well select them all. It doesn't hurt anything if you select all of them. So I select analysis, and then correlate with is going to be body fat percent. Okay. On the options tab, I'm going to just use the default statistics, and under the type of plots, I would suggest using an individual scatter plot option. No problem with including the ellipse, that's fine, leave those settings fine. And then you're going to want to go ahead and set the number of variables to plot to 10, which is the maximum right now. So that's all you have to set up. And then I'm going to run it. And I'm going to make my result space a little bit larger. Now, one thing it will show you is, you'll notice here in this matrix or this table up above, is it will show you all of your correlation coefficients. So this should be all of them. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, so it's all of them. But you'll notice it'll only do 10 scatter plots. So, you know, you're going to have to do graph the last few. So it's only going up to, for variables, you'll see it stops at a particular, the 10th one. So what you're going to want to look at is look at each one of these relationships. And you want to try to see some kind of linear relationship here. All right, so here that looks reasonably linear. Okay, now we're going to see in a moment this isn't great because this, while it looks linear, there's also virtually no correlation, and you'll see why in a moment. We're going to come back to this one, so keep this one, the body fat and height, in mind for a moment. Okay. This one has a very strong linear pattern, and you're noticing, look at the correlation, 0.6 here. We're not surprised that it looks linear because our correlation coefficient is a high number. Remember, the closer it gets to 1 or -1, the stronger the correlation. So this is pretty strong. Ditto for this one, it's a 0.5. This is a 0.7. This is a 0.8. This is a 0.6. This is about a 0.6 as well. A 0.5. This is a little bit low, so we're maybe want to keep a look at ankle circumference, and that's where it stops. Okay, so ankle circumference is the last one that it plots for us. So you'll see we're going to have to do now extended bicep, forearm, and wrist alone. Now I want to return to a couple of these. Okay, look at this one. This is height and body fat percent, and while it looks linear, you'll really notice the correlation here is only 0.08 or -0.08. So that's virtually, no correlation at all. But one thing you'll notice is that we do have an outlier way out here on the left-hand side. Oops. And that outlier is causing this graph to be very compressed to this side. So really what most of our data is between about 160 centimeters, I believe that's height in centimeters, and 200 centimeters. So if you were to think about pulling this graph all the way over, if we started at 160, all right, then you would probably see that there was very little correlation. Look just how scattered this is for all body fat percentages. It's kind of just all over the place between these heights. So I would advise at this point to probably leave height completely out of the regression analysis, okay? So, write that down somewhere and say, oh, I'm not going to use height. Now, how am I going to know on an exam, should we use it or should we not use it? My recommendation is take a look at the correlation coefficient. And I would say, for our purposes for an exam, I would say on an exam, please leave out any covariates that have a correlation coefficient of below 0.2 or below -2, or -0.2, sorry. So below 0.2 or below -0.2. So this one just makes it, this is about 0.3, but you'll notice this one is -0.08. So way below our cutoff. None of the other ones are low enough to exclude. So far just height. I think there is one more bad one. It's ankle circumference, but it just makes it's 0.266. So we're going to include that. Now we're going to have to do the rest of them. Now we can look at the correlation coefficients for all of them without graphing them. So ankle was our last one. You notice extended bicep is 0.49 and forearm circumference is 0.36 and wrist circumference is 0.34. Let's just do them, just to take a look at them, even though we know that those are all going to pass the test if we use that test of 0.2 for our correlation coefficient, but might as well. So we want to do extended bicep, forearm, and wrist. So we'll delete these covariates and just run the task again. And we can see here we have a correlation of about 0.5, here 0.36, here 0.34. So, and again, they're pretty linear. You could picture a line going through this ellipse. That's why I include the ellipse in here, so it kind of gives us a feeling of the shape of that relationship. So right now, I'm thinking of leaving height out of my regression analysis, okay? So now we're ready to actually do the multiple regression analysis. I'll close out of our correlation analysis task. I can close the data set too, okay? And we're going to now go to linear models, and we're gonna go to linear regression. And this is the same task you use to do simple linear regression, just two variables, x versus y. It's the exact same task you use, but we use a few more of the settings. All right, so our dependent variable is the variable that we are trying to predict. So in our case, it's body fat percent. So we're gonna select that and click OK. And then we're gonna scroll down to continuous variables on the bottom. Make sure you do not do this in classification variables. It's very easy to kind of mistakenly go in there and do this. So you wanna do this down in continuous variables. And here we're gonna pick all of our covariates that we believe may predict body fat percent. Now we're going to leave height out because we've already realized that that has a very low correlation and virtually no linear relationship between itself and age. So we're just going to include weight through wrist circumference. By the way, I'm holding down the control key on my keyboard to select all of those. Click OK. All right, next thing we're going to do, go to the model tab. Now here we have to reinsert all of those covariates again. So even though you did it here on the continuous variables section under data, here on model, we have to go to edit, select all of them, and click add, okay? And then click OK. All right, now you'll notice as soon as you set up that one tab here on model that SAS starts building the code for this particular multiple regression analysis. On the option screen, you're gonna leave everything as is. You're not gonna make any changes at this point. And then we're going to go to the selection tab. Now here is where you get to choose what your variable selection technique is going to be: forward selection, backwards elimination, or stepwise selection. So we're going to use backward elimination for the purposes of our course. Now you're going to have to set a drop down here where it says add remove effects with. You're going to go ahead and change that to significance level. So if you remember, what's happening is each one of these covariates has a null and alternative hypothesis. The null hypothesis is that the covariate is insignificant to the model, okay? And the alternative is that the covariate is significant to the model. So therefore, the only covariates you're going to want in the final model are covariates with a p-value for each one of those hypothesis tests of lower than 0.05. Because as soon as they're lower than 0.05, they reject the null hypothesis that the covariate is not significant to the model. So therefore, I'm using the significance level to add or remove covariates, or as SAS calls them, effects in the model. The stop adding and removing effects with is also going to be significance level. So in other words, it's going to keep removing covariates out of the model until they're all, the ones that are left are below 0.05, okay? So it's gonna go from the highest p-value, the ones that are close to 1, and it's gonna remove them one step at a time until it gets down to the covariate that removes, that has 0.05 or lower, and then the only ones that will be left will be the ones with a p-value of lower than 0.05. That is automatically set up here as the significance level to use, so just don't touch that. And you're going to select the model by the default criterion, so you don't have to make any changes there, okay? You're not going to have to change anything on the selection statistics. And here, for your selection plots, you can do a panel of plots. That works out just fine. And then selection process details, a couple different ways you can do this. If you just want to quick and dirty and you want to see the results very quickly, you can use selection summary. If you use details for each step, it's going to show you every single step of the multiple regression process, of the elimination process. So it's going to show you going from highest p-value to lowest p-value. I'm actually going to keep it on details just so I can kind of show you what's happening, and then we can change it back to selection summary when we're done, just so you can see the final model, okay? Don't worry about any of the other tabs such as output or information. You're done making changes. So you're going to go ahead and run this task. And as you see, it takes a second to run and you have your results. So let me just make our screen larger here and shrink this. So let's go through it. All right. Notice it starts with 12 effects because we removed height. We originally had 13. Okay. And now we're going to scroll through. So this is step 0. In other words, every single covariate is in the model. Remember, we're using backwards elimination. So that means it starts with all the covariates in the model, and we're removing them one at a time from highest p-value to lowest p-value until all the p-values for each of the effects are lower than 0.05. So you notice we certainly have some covariates here that have p-values of greater than 0.05. In fact, if we look through each one of these, we can see that, look at chest circumference, that's a 0.96. So that's a really high value. You bet that that's going to be the first one to go. So what's going to happen? Well, the multiple regression process is going to remove the highest p-value covariate, which is this one, chest circumference, okay? Removes that. And then when that happens, because we have some collinearity, which means interaction between multiple effects in the model, when we remove chest circumference, the p-values of other covariates or other effects will change. So that's why you can't just get rid of all of them at the same time. You have to do it one step at a time. Because when I take one out, if there's any relationships between that variable I just took out and any of the other variables in the data set, all the p-values are going to change. So there definitely is going to be collinearity. Let me just give you an example. If I look at chest circumference, it's 0.96, right? So we're going to get rid of that one first. Now just take a note of maybe the couple above it. Neck circumference's p-value is 0.07, and weight in kilograms is about 0.00. I mean, it's, virtually 0. Watch what happens when we remove chest circumference. We're going to go down to the next step, okay? Notice that neck circumference is still 0.0708. But notice it's changed. It went from 0.0714 to 0.0708. And notice weight in kilograms went from 0.0033 to 0.0018. So these p-values change when you remove a variable. So you have to do this one step at a time. Okay, so we got rid of chest circumference. All right, and notice it even tells you in step 1, the effect removed was chest circumference. We're going to go to the next highest one. So if we scroll through, it looks like the next highest one is going to be knee circumference with a 0.61. I don't see any that are higher than that. So you notice step 2, it removed knee circumference. So it's going to do that one step at a time. Keep going and so on and so forth. The next one it removes is ankle circumference. The next one it removes is extended bicep circumference. The next one it removes is hip circumference. And notice at this point now we're getting close. Okay, we have maybe 1, 2 that are above 0.05. So you can tell here, the next one we're going to get rid of is thigh circumference, and then we should be able to be done, right? After neck circumference is gone. But remember, things will change. So something that was above 0.05 might go to below 0.05. Something that was below 0.05 might go above 0.05 when we remove an effect. So when we get rid of thigh, we expect the only one left we have to get rid of is neck. Okay, so I get rid of thigh, and now notice neck is still there. All right, so it looks like, yep, neck is going to be the last one, right? So we remove neck circumference, and we are able to stop. All right, so we're good. Now, that doesn't always happen so beautifully. Sometimes we remove one, and then the one that we think everything is going to be below 0.05, and removing that one effect made something else go above 0.05, so you have to be careful. So once we remove neck circumference at step 7, you notice all of our p-values are below 0.05. So that's going to be our final model. So you'll see here our backward selection summary. This is these are all the variables here. If you notice, the parameter estimates that are left are at step 7. You removed all of these. Okay, these are all the ones that that are gone. All right, and if we scroll down, you will see the selected model. This is the last step, this selected model. The only variables it has in it is, of course, the y-intercept, because there's always a y-intercept. It's a line after all. The weight in kilograms, the abdomen circumference, the forearm circumference, and the wrist circumference. Okay, so all of these p-values are below 0.05. So it's really great. We've been able to take a look at this. We've removed all the covariates that are not statistically significant. So we went from 13 originally covariates to just 4, wrist, forearm, abdomen, and then the weight. That's it. That's all we have left for this particular model. So now if you're going to try to predict someone's body fat percentage, you don't have to take 13 different measurements. You just take 3 circumference measurements, you weigh them, and you're done. And you can plug those into the equation. So that brings us to our next point. Well, what's the equation for this line? So let's go ahead and write that equation down. So I'm going to go ahead, create a blank Word document just so we can write this equation down. All right, and what we're going to do is make my font size a little bit larger. So these estimates, this estimate column is the coefficients for each one of these variables in the line. So each one of these is the actual coefficient, and then you have your y-intercept. So if I were to write this out, I would say that my body fat percentage is equal to, and I like to start with the covariates and then do the intercept last. You can do whatever you'd like. So we'll start here. Weight kilograms is negative 0.29. If you don't mind, I'm going to round to 2 decimal points. So this is going to be negative 0.3. And that's going to be times our weight in kg plus, you notice abdomen, if I round that, it's pretty much 1. So, I guess you could say 1 times abdomen circumference plus we have about 0.47 times forearm circumference, so 0.47 times forearm circumference minus, and our last one is minus 1.5 times wrist circumference, so minus 1.5 times wrist circumference. All right, and now I'll do my y-intercept, and my y-intercept is negative 34.85, so minus 34.85. All right, so if you give me someone's weight in kilograms, their abdomen circumference, their forearm circumference, and their wrist circumference, I can plug those values into these parentheses and give you a body fat percent. Okay, very, very easy to do. So that's my final equation. Right, that is my actual linear equation. All right, basically just one more step is just to check a couple last diagnostic plots in SAS Studio. One of the things we want to take a look at is that we want to make sure that our equal spread condition and our nearly normal condition are also satisfied. So what I want to take a look at first is my equal spread condition. And what that means is I want to take a look at my residuals plotted against my predicted values. And that you can find right here in the fit diagnostics. Here's my predicted values on the x-axis. So all these are body fat percentages. And here is my residuals. Remember, a positive residual is a point that lies above the line. A negative residual was a point that laid beneath the line, sorry. So if you take a look at it, what you want to try to see is you want to make sure that that pattern of residuals is pretty uninteresting. It's spread all over the place. And it indeed is. I would be concerned if I saw any kind of fan-shaped in either direction, and I don't see that. So this is an uninteresting plot, so therefore my equal spread condition is satisfied. And then finally, my nearly normal condition means if I take a look at my residuals and I plot a histogram of all my residuals, then they're nearly normal. And if you take a look at this, this is certainly nearly normal, right? So looks great, all right? In fact, if I look at my QQ plot right above it, you notice the residuals lay pretty much on the diagnostic or on the diagonal line here, and therefore my residuals are nearly normal. So it passes all the tests that this is a good model as well. So that's pretty much it. That's from start to finish a multiple regression model in SAS. And if you have any questions, feel free to ask me or the TA. Thanks.